One of the most fascinating developments in modern nutrition science is the realization that what we eat doesn't just shape our metabolism, it shapes how we think, learn, and age. Artificial sweeteners, long assumed to be inert calorie savers, are now under careful scientific scrutiny. And emerging research reveals that these sweeteners can influence the brain indirectly, not by feeding neurons directly, but by reshaping the microbial communities in the gut. For older adults, whose microbiomes are already shifting with age, these microbial changes appear to have measurable effects on memory, attention, and cognitive resilience. Recent studies have followed adults over 60 who regularly consume common non-nutritive sweeteners such as sucralose, aspartame, acesulfame K, and stevia-derived glycosides. Using microbiome sequencing, blood biomarkers, and cognitive tests, researchers discovered that even mild daily intake can alter the balance of gut bacteria in ways that ripple through the gut-brain axis. These shifts don't necessarily spell harm. In fact, some findings point to opportunities for personalized dietary decisions that help preserve cognitive clarity. One of the clearest patterns is that certain artificial sweeteners reduce the abundance of butyrate-producing microbes, while others appear to increase microbial diversity. Sucralose and aspartame, for example, tend to suppress bacteria like Faecalibacterium and Roseburia, key producers of short-chain fatty acids, SCFAs, that lower inflammation and support neuroplasticity. Reduced SCFA production is associated with sluggish attention and lower cognitive stability during tasks that require sustained focus. But the story is not uniformly negative. Several newer sweeteners, particularly Rebodiacide M from stevia, allulose, and monk fruit extract, show a more promising profile. Instead of suppressing SCFA-producing microbes, these compounds can encourage growth of beneficial genera, such as Bifidobacterium and Akkermansia. These microbes support gut lining integrity, stabilize metabolic signaling, and release metabolites that enhance BDNF, the brain's main molecule for strengthening synapses and forming new memories. Older adults consuming these sweeteners often experience better glucose control and fewer inflammatory spikes, both of which contribute to clearer thinking. What truly elevates the importance of these findings is how the microbiome mediates attention and working memory. In controlled trials, older adults whose gut bacteria remained diverse and SCFA-rich performed better on reaction time tasks, verbal recall, and alternating attention challenges. This suggests that the impact of artificial sweeteners on cognition is less about the sweeteners themselves and more about how the microbiome responds to them. When microbes thrive, the brain receives a steadier flow of anti-inflammatory and neuromodulatory compounds. When they falter, cognitive fatigue becomes more likely. Another fascinating mechanism involves vagus nerve signaling. Some artificial sweeteners reduce the activity of gut neuroendocrine cells, which serve as the first relay in the gut-brain neural network. When these cells are understimulated, vagal tone tends to decrease, slightly dulling the brain's responsiveness and stress resilience. But sweeteners like allulose or certain stevia fractions maintain, or even increase neuroendocrine activity, suggesting they may help keep this neural pathway healthy in older age. It's also becoming clear that context matters. Artificial sweeteners paired with high-fiber diets tend to cause fewer microbial disruptions and may even amplify the benefits of fermentable fibers. In one trial, older adults consuming both sweeteners and fiber saw their SCFA levels rebound more quickly, indicating that a supportive diet can buffer any potential microbial imbalance. This points to a hopeful, practical insight. The effects of sweeteners are modifiable, and the microbiome remains highly adaptable even in later decades. What makes this research so encouraging is the sense of agency it gives older adults. The goal is not to demonize artificial sweeteners, but to understand their nuances. Some sweeteners may not be ideal for individuals with already low microbial diversity, while others could be compatible with a microbiome-supportive lifestyle. As personalized nutrition advances, people may soon be able to choose sweeteners based on their gut profile, preserving both metabolic balance and cognitive clarity. The broader takeaway is deeply positive. The aging brain is profoundly responsive to gut health. By paying attention to how foods, including sweeteners, affect the microbial ecosystem, older adults can shape their cognitive trajectory in meaningful ways. The microbiome's influence on memory, attention, and mental stability is not fixed. It can be supported, strengthened, and guided. In the end, The message from this research is one of empowerment. Artificial sweeteners are not simply good or bad. They interact with a dynamic biological system that we can nourish through fiber-rich diets, fermented foods, active lifestyles, and thoughtful choices. As scientists uncover more about how sweeteners influence the gut-brain axis, it becomes clear that the aging brain still has remarkable capacity for resilience. With the right support, that resilience can shine long into later life.